Good afternoon. We are Group 1 and we have done a project called Automatic Irrigation System using the 8051 microcontroller. So, as you can see, the components of this project are the LCD display, the ISP programmer which is used to transfer the code from the computer to the 8051 microcontroller. This is the microcontroller and this is the programming board used for it, and this is the 9 volt DC fan which is used to depict the pump in this case, and this is the soil moisture sensor, and there are two samples kept here. One is the dry one and one is the wet one. We are using the 12 volts power supply for this project, and the LCD requires a power supply of 5 volts which is taken from the board. And this is the relay module. This is the another output device which is connected to the fan. It controls the DC fan, and this is the DC to DC voltage regulator, sorry. And this is the potentiometer which is used to monitor the which is used to control the brightness of the LCD display, and the trim pod is used to control the contrast of the LCD display. So this is the soil moisture sensor which is taken for the input. Okay, so this is the basic circuit of our project. The demo of our project is when I on the power supply. Now the soil moisture sensor is in the dry sample. When I on the power supply, the title comes as soil irrigation system, and then after a few seconds the soil moisture sensor sends the input to the microcontroller, from which it comes to a conclusion whether the soil is dry or wet. If the soil is dry, the microcontroller gives instruction so that the LCD displays motor on, and the fan will also get on. In this case, the fan depicts the pump so that we can assume that the pump is pumping the water into the soil. So there are three ports which have been used in this microcontroller: one input port and two output ports. The input port, which is a soil moisture sensor, is connected to port 2.0. The relay module is connected to port 3.0, and the LCD display is connected to the port 1 fully. Okay, so after pumping the water, the soil eventually gets wet. In this case, the fan automatically turns off, and the LCD display also shows motor is off. So this is the basic representation and demo of our project. Thank you.
Hello. Now we will learn how the program works. It controls a motor for an irrigation system using the 8051 microcontroller. It also shows message on an LCD screen. The LCD is connected to port 1, the motor is connected to port 2.0, and the switch is connected to port 3.0. Here comes our main loop. This is the main control loop, keeps checking the switch AC. If the switch is not pressed, shows motor off and the motor stays off. If the switch is pressed, then it goes to motor on loop. After that, it always come back and repeats. The motor on loop runs when the switch is pressed. First clears the LCD, then displays motor on message on the LCD, and then turns on the motor on, and he waits using delay, then goes back to the main loop. The loop LCD initialize. It sends several commands to set LCD mode like clear display. Each command is followed by a delay. LCD command loop and LCD character loop. These are not full loops, but they use a simple small step with enable pin. Set enable pin to high first and wait using delay, then set enable to low. LCD string loop prints a whole message on the LCD. First takes each letter by memory from DPTR. Sends each letter to LCD using LCD character loop. Repeats until it finds a loop 0 at the end of the string. And the delay. It makes a small delay for timing. Set two counters R6 and R7 to 52 to 55. First loop DL2 reduces R7 to 0, then outer loop DL1 reduces R6. This creates a delay before the next action. Then here are the message 1 which is irrigation, message to system, message on, which is motor on, message off, which is motor off. And this is our end of the program. Thank you.